Okay, so we continue with our lesson in redox reactions. So now we're remaining with balancing. So we'll do a recap and then we continue with examples. Okay, so we said we have about 7 steps. Okay, so this looks a lot, but we'll go step by step. So we start with here. These are the steps for balancing redox reactions. So step 1, you split the given reaction into 2 half reactions. So one would be an oxidation half reaction, and then the other one, it will be a reduction. So this is where redox comes from. So it's starting from here, redox. Here, if you see it, redox reactions of oxidation and reduction. So I have to identify which one is oxidizing, which one is reducing. Yeah, so I hope you remember those definitions. The gain of electrons, the loss of electrons, gain of hydrogen, loss of hydrogen, gain of oxygen, all those. So when you identify your half reactions and then you go to step 2, which is balance elements other than hydrogen and oxygen. So if you have copper, you balance it. If you have anything, aluminium, anything except if it's hydrogen or oxygen, because these, they are special, we're going to balance them in their own way. So that's step 1 and step 2. And then now moving on to step 3 here. So step 3 is where we balance oxygen. So we balance oxygen, that is our step 3. Okay, so nothing much here. So we balance oxygen by adding water. Yeah, we balance oxygen by adding water molecules. Step 4, we then balance hydrogen. So we balance hydrogen by inserting either hydroxide. So this is if something is acidic. If they tell us that the reaction is an acidic medium, we balance using hydroxide. And then if it's in basic, we use these two. So these, they are used when the reaction is in basic medium. Okay, so that's step 4. So I think these steps, they are very easy. Okay, you can be able to remember them. Balance anything other than these two, and then later on, that's when you balance them. Yeah, and then now step 5 here, we balance the charge by putting electrons. Yeah, and then step 6. Okay, so that was our step 5. Step 6 here, we now multiply the 2 half reactions by a factor. Yeah, so the factor is the number of electrons. Yeah, we just multiply to make sure they cancel out later on, and then finally we add the 2 half reactions. So step 4 here, it can be problematic when balancing in basic medium. So a breakdown of step 4 is where we say we balance hydrogen by inserting 1 water molecule for each missing hydrogen. So if like on the left we have 2 missing hydrogen, so like if on the left hand side we have 2 more hydrogens, it means on the right hand side we are going to put 2 water molecules. Yeah, so like let's give a very simple example. So like here on the left hand side, if we have maybe 3 hydrogen, it means on the right hand side, to balance this, we're going to say we put 3 water molecules. Although here you can question, why have we put 3 water molecules? Because hydrogen will now be 6. So this is where now the other part comes in. So the other part is, after balancing with water, we're going to insert hydroxide ions. So if you put 2 water molecules on the other side, it means you also put 2 hydroxides. Yeah, just like that. So these are the steps which you have to remember. So let me summarize them on the next picture. Okay, so that's our summary. So I can zoom in just for you to see it clearly. So number 1, you just split. You identify your 2 half reactions, and then what will be next is just balancing. So remember, you balance first things except hydrogen and oxygen, and then you go to oxygen, and then after oxygen, hydrogen. After hydrogen, you balance the charge using electrons. Yeah, so these are things you should have on your fingertips. Try to understand as much as you can. Yeah, so now straight away let's go to an example. Okay, so our first example is how we balance in acidic medium. So here it is. It says balance the following redox reaction in acidic medium. So the steps are just the same. The only difference between acidic and basic is on step 4. On step 4, when balancing hydrogen, for acidic we balance using hydrogen ions, but for basic we said we balance using water and hydroxide ions. Okay, so we'll be making reference to the picture which to those steps. So step 1 split the reaction. So I'll just do this for this example. Later on I want to be coming to the picture. So step 1, let us split the reaction. So what do we have? We have copper sulfide giving us it's giving us sorry about that. Where was I? Okay, yeah, so let's pick it up. So one, to identify the half reactions. So you just have to analyze. So we have these 2 things. So one of these will be the oxidation, and then the other one, it will be the reduction. So if you look at sodium here, this sodium, we can calculate the oxidation number. Even this side, we can calculate the oxidation number so that we can know what's happening. So if the oxidation number is increasing, that's oxidation. If it's reducing, it's reduction. So what's the oxidation number in this nitrate ion? So we're going to say the oxidation number for nitrogen is X, we don't know, plus we have a 3 here, so 3 times the oxidation number of oxygen, it's 2. Okay, so we're going to say 2 here, and then everything will be summed up to -1. So the charge which is there is what we sum to. Okay. Okay, so what do we have? We're going to have x plus 6 is equal to, so this is equal to -1, and x is equal to, oh, this was supposed to be negative. So the oxidation number of oxygen, it's -2. Yeah. So -2 times 3, it's -6. This positive times negative, it's negative. Okay, so we have x minus 6 will be equal to, when this goes to the other side, we're going to have 5, 6 minus 1. So meaning the oxidation number of nitrogen here, it's 5. So what about the oxidation number here? So the oxidation number there, we're going to say nitrogen, we don't know the oxidation number, x, plus oxygen, it's -2. So everything is equal to the power. If there's no power, we say everything is equal to 0. So the oxidation number of nitrogen is 2 positive, because here we have -2. When it goes that side, 0 plus 2 is 0, or it's 2. So you're able to see that the oxidation number of nitrogen, it has reduced from 5 to 2. So this is reduction. So this is the reduction half reaction. So this is being reduced to that. Okay. And then we can also analyze copper. So the trick here, usually if you determine like this is oxidation, you might want to say this is, if this is reduction, you might want to say the other one is oxidation, which is usually the case. Yeah, but you just have to be sure to prove. Yeah, so here what you can look at sulfur. Sulfur has no oxygen, but here it has oxygen. Remember from the 6 definitions I gave you in the document and in the previous video, if something gains oxygen, then it has been oxidized. So this sulfur has gained oxygen, meaning it's undergoing oxidation. And for this one, you can see that we now have an ion, meaning it lost electrons. So this is oxidation. Okay, so this was our step 1. So this, it wasn't like the electrons were not yet lost. Like on the other side, we have an ion. For it to be positive, meaning some electrons were lost. And then for copper, it gained electron. So this is reduction. I hope I haven't lost you here. So from here now, we're going to write the 2 half reactions. So we said the oxidation half reaction is the one which is having copper sulfide, and then it's giving us copper ion and sulfate ion. This is the oxidation half. And then the reduction half is where we have this nitrate 3. ion. Okay, so is this clear? Okay, and we have is it nitrogen monoxide like this? Okay, so that's our nitrogen monoxide. So we're done with step 1. Step 2 is where now we balance things other than hydrogen and oxygen. So step 2, we balance everything except these two. So we look at copper. Copper, here we have 1, here we have 1, it's balanced. Sulfur, we have 1, here it's 1, it's balanced. Nitrogen, 1, even here 1, it's balanced. So everything is balanced. And then now that's when we go to oxygen. Oxygen, we balance it by inserting water molecules. Okay, so here we don't have any oxygen, but here we have four oxygen on the left. So we're going to say on the right, we'll introduce four water molecules. Yeah, so that it's balanced with this side. So 4 water molecules and copper sulfate to give us this, plus sulfate ion. So we've balanced water, and then even we've balanced oxygen even down here. So what we already have is this, I don't know how you call this, nitrate ion and nitrogen monoxide. So we look at oxygen. Here oxygen is 3, here it's 2. So if here 3, here 2. So to balance, it means we need to add another oxygen. So meaning we'll add 1 water molecule. So we don't have to write Deka1. We can just omit it. So that's our step 2. Easy stuff. We go to step number 3. So we can first write what we have. We have 4 water molecules and this. Okay, so that's what we have. Yeah, so I've just written we have 4 water molecules, and I've also added this. So it's very easy. You balance anything else other than hydrogen and oxygen, then oxygen, then now hydrogen. So how do we balance hydrogen? We say here we have 8 hydrogen atoms, but here we don't have any. So we can put 8 hydrogen ions. Here we didn't have, here we now have. We have put 8, so that hydrogen on top is balanced. What about here? Here we have 2 hydrogen molecules, two hydrogen atoms. So meaning this side we can put 2 hydrogen ions. Okay, so I hope we're together up to this point. So now we can go to the next step. Okay, so for balancing hydrogen, that was the fourth step. So what did we say our step number 5 is? So step number 5 here, we have balanced the charge by inserting electrons. Okay, this part is confusing for a number of students. Okay, so we'll get through it together. So firstly, I'll write what we have written so far. So far we have four water molecules. Okay, so this is that, and then we do the same here. So I think I've even made a mistake up there. Okay, so let's correct it before we get far. So here I don't know what math I was using. Yeah, so don't get lost. So on this part, here, so here we had 3 oxygens, and then here we had 1. So we have 3 and 1. So to balance, we're not going to say we put 1 water molecule. We have to put 2, so that 2 plus 1 is 3. So I think I've even said this now, I wrote something else. So we put 2 water molecules, so that 2 plus 1, it's balanced. Yeah, so please, I hope you are writing this somewhere so that you can easily follow. Okay, so we can take it up again. We are balancing hydrogen ions. So on top we said hydrogen here, it's 8. No wonder we have put 8 hydrogen ions here, because we have 4 hydrogen atoms. Okay, and then we come down here. So down here we have, so this was supposed to be 2 water molecules. So here we don't have any hydrogen, but here we have 4. So meaning on this other side we're going to have 4 water molecules. Okay, so I can write that better. So we're going to have 4 water molecules, like that. Is it 4 water molecules or 4 hydroxides? What's wrong with me today? So these are 4 hydroxide ion, 4 hydrogen ions. Yeah, remember we balance hydrogen using hydrogen ions. Under here we had put 8 hydrogen ions. Okay, so I hope you've made that correction and we can proceed. So going to the next step. So we've balanced hydrogen. So if you're writing down this, you'll be seeing how things are flowing. Make sure you're spacing your work, yeah, and write something better. write neatly. Okay, so quickly, we've balanced hydrogen. Now I want to balance the next thing. It is the charge. So before we balance the charge, this is the part where I was rewriting everything here. So it just rang a bell that we could have made a mistake somewhere there. So initially we had put 2, but we have now corrected. We have NO2H. Oh, okay, so is this the correct thing? Yes. So now step 5 is where we balance the charges. So one thing on balancing the charge, there's something I've been mentioning in the document. You put the charge where we put electrons where there's a higher charge. Yeah. So you don't balance the charge by increasing it, you balance by reducing it. So like here we don't have anything that has a charge, meaning the charge here it's 0. But what about this side? So this side we have positive 2, we also have negative 2 as the charge, and then we have this positive, and we also follow the coefficient. So we're going to say 8 hydrogen ions. So we also have positive 8. So meaning we'll say 2 plus negative 2 it's 0, plus 8 it's 8. So the charge on the right hand side it's 8. So we've just said 2 minus 2 it's 0. So we remain with positive 8. So on one side the charge is 0. It feels so sad, you see, but on the other side the charge is it's 8. I'm sure it's even smiling like, yeah, me I'm 8. So now remember we balance the charge by putting electrons where the charge is greater. So since here we have positive 8, it means we're going to introduce 8 electrons so that they are neutralized, so that this guy can become happy. Yeah. So 8 plus this 8 electrons, it simply means negative 8. So 8 plus negative 8 is just 8 minus 8, which is 0. Yeah, so this is how we balance electrons. You just look at the charge. Where it is more, that's why we put electrons. So that this guy who is sad can now be happy. Okay, so don't be sad. Be smiley all the time. So now I'll balance the electrons from here. So for you might have to rewrite this again so that the steps are clear. Yeah, but sometimes you can just skip some. So like here I'm going to add 8 electrons, so that 8 minus 8 will remain with 0. And then here now we come 4 hydrogen ions. So the charge we have positive 4, and then here we have negative 1. So 4 minus 1 is 3. So meaning the charge on the right hand side is 3. What about on the left? We don't have anything on the left. We don't have any charge, so the charge is sad. Oh, the charge is sad. It's 0. So to balance the charges, we're going to say here where we have more, we're going to put electrons. Like we're going to put 3 electrons, so that 3 minus 3 will remain with 0. Yeah, so this is how you balance. You just check where the charge is more and you put electrons. So meaning on the left hand side you put electrons plus everything. And the trick here is so this is a mega tip. So you know you are doing the right thing when, like, on top, if the electrons are put on the right hand side, you just have to know that downwards on the bottom part the electrons should be on the left. If the electrons were here, if we had put these electrons here, it means down there they could have been here. Yeah, so that's one thing you have to know. So what's our next step? So our next step is step 7. Add the two half reactions and cancel spectator ions. Okay, so how do we add and how do we cancel? So we're going to write a very long list. Yeah, we're going to write the reactants. You can see these guys here. Yeah, so is my red ink. So it's refusing. I think this is a sign that we should knock off. So these are the reactants. So these reactants, we're going to put them, so like this is our arrow. The reactants will be on the left and all these products will be on the right. So we can add the reactants together. So we start with the things on top. I'm sure you can see we have four water molecules. We have copper sulfide. We're done on top, and then so I wrote this. So now so these are the reactants. So I've already written these which are on top. So let me also write these down here. We're going to have yeah, so you can write in any order. So we'll start with the same one: 3 E, 3 electrons, 4 protons. Yeah, so these are like protons, the hydrogen ions, and nitrate ion. So now we're going to write these on the right. I wish we had space. Okay. So where are you guys writing? Yeah, it's very good to be writing as you are playing. Okay, so let's write things on the right. You can screenshot or write somewhere. So we have this copper, the copper ion, copper 2 ion. We have the sulfate ion, and then we have 8 hydrogen ions and 8 electrons. And then we have nitrogen monoxide and water. And water. So there's like a 2 here. So you have to be careful when balancing these because mistakes are very, very, very common. Like you can make a mistake anywhere. Okay, so this is what we have here. We now cancel spectator ions, things found on both sides. So like water, you can see we have 2 here, and then on the other side we have how many? We have 4. So we can cancel out. So Is it 4? Oh, wait up. Okay, so we added the electrons. This was step. What step was this? So we balanced by adding the charge. We're just on step 5. Okay, and then step 6. I forgot about this. I'm sure most of you are wondering, why are we not multiplying? Yeah, so I went to step 7 where we add. So step 6 is multiply the two half reactions by a factor to make sure that electrons are equal. Yeah, so we have to multiply by the respective number of electrons. So before adding them, so but you have seen how we add this, we write. So but we are supposed first to multiply by the number of electrons. So we can quickly wrap this. Okay, so we need to multiply by factor. So what's this factor? This is whereby you get to check. Oh, so like on top here you can see we have 8 electrons. Down we have 3. So what we're going to do is we multiply everything. On top we multiply by the number down here. We multiply by 3. And then down we multiply by the number on top, which is 8. You see that? Yeah. So that later on the electrons can cancel. So in the balanced redox reaction, there shouldn't be electrons anywhere. So we're going to say 3 times 4H2, we're going to have 12. So I'm going to try writing as small as possible. So 12H2O plus 3 times this, it is 3 that copper sulfide, giving us 3 times copper ion, it is 3 copper ion, 3 times sulfate, it is 3 sulfate ion, and then 3 times this, it's 24 hydrogen ions, and then 3 times 8 electrons is going to be 24 electrons coming down. 3 times, oh sorry, we're 8 times 3 electrons, we're going to have 8, oh sorry, 3 times 8, it's 24 electrons plus 8 times 4 hydrogens, we're going to have 32 hydrogen ions. Yeah, and then 8 times this is just going to be 8 nitrate ion, and then that's when we're going to the right hand side. We're going to have 8 nitrate ion, or sodium oxide, and 16 water molecules. Okay, so I've multiplied by a factor. Now that's when we can add. So it's going to be a very lengthy process adding, but we have to do that so that you see things clearly. But here you can just cancel in advance, like we check on the left. So the things on the left, they are these before the arrow. So if you check, we have 24 here, even there we have 24 electrons. So 24 electrons can go away. And then so here initially you are going to write 12 H2O, yeah, and all that. You write each and everything. So let me just refer to the okay, just here. So the video is even this long. 24 electrons have gone. We can also cancel out the hydrogen ions. Here we have 32, here we have 24. So like we're going to say the kind of cancelling is like, let's say it means on the right hand side, let's say if we have 4 hydrogen ions, and then on the left we have 1, 2. So to cancel, it simply means we say this goes with that, this goes with that, we remain with 2. So it's just the same as saying 4 minus 2. So it's the same here. So like here we just said 24 minus 24, it's 0. So everything has gone away. So we'll say 32 minus 24. So all these 24 will go away. And then on 32 we're going to say from 32 when we cancel 24. What are we getting? That should be 8. Is it? Okay. So meaning here, yeah, so here we have 8. So meaning when this 32 cancels with a 24, here where this 32 will remain with 8. And then we can also check what else is cancelling. Water. Water we have 12, there are 16. So all of these 12 will go, and then we cancel out with 12 of them here. When we remove 12, we'll remain with 4. So we cannot cancel out this because it's not on the other side. Yeah, and then we can't cancel this one also. So meaning what we remain with is, yeah, so I skipped the part of writing the half reactions, but I'm sure you saw. You just write this, you write this, and then you put an R. Yeah, it's because of time and space. So we'll remain with 3 copper sulfide plus here, not everything went, remained with 8 hydrogen ions and 8 nitrate ion, so that we get 3 copper ions. So I'm now writing things on the right hand side, and 3 sulfate ion. This one, the hydrogen ions went, electrons all cancelled. We have 8 nitrate, and we have 4 water molecules. Alright, so this is the balanced redox reaction. Yeah, so like I said, mistakes are very common. Yeah, so you can start checking. Copper, is it balanced 3-3? Sulfur, here you have 3, there we have South, I think I can see 3. Yeah, so everything is balanced. Okay, so we end here. I know the video is very long, only few people even get to the far end. Yeah, because of the time it has been made. If you observe, oh, it's 6:21. Yeah, so can I tell you a secret? When you scroll back to where the video started from, I was recording it on 6th December. And then I was so tired I had to go and sleep and then continue. Okay, so we'll end here. Let me know if you have any problems anywhere. So usually you can refer to the document, there are more examples there. So I think the next thing now I'm doing is just balancing in basic medium, just one example. And then at the end of the Megaminds document, you should be able to see those exercises and answers. Yeah, you can try them out. So for now, we can say have a good morning.